Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving of logarithmic equations containing different bases, and you cannot use any calculator to get to the solution. We will be solving a single logarithmic equation in our today's session, and of course the logarithmic terms will be having different bases. Okay? So without any further delay, let us start with our today's session. First of all, let us look at the given question. It is solve the equation log of x plus 14 to the base 4 minus log of x to the base 2 equal to 1. And we are seeing this equation is having two logarithmic terms and they are having different bases. One is having the base as 4 and the other is having the base as 2. And if you have a logarithmic equation where the logarithmic terms are having different bases, the first thing that you have to do is to bring them to have the same base. They should be having a common base. And how can you make them have a common base? You can select the common base as one of these two numbers, or you can take some other number, say base 10, or we haven't learned the natural logarithms till now, so we will not be going for that. If you know the natural logarithms, then you can take the base to be e as well. But in our today's session, we will be taking the common base to be one of these two numbers. I keep this as an exercise. Try to solve this equation taking the common base as base 10. See what value of x do you get. Okay? But for our today's session, we will be taking the common base as one of these two numbers. And it is always easier to convert the larger number to a smaller number as the base rather than converting the smaller number to the bigger number. So we will be converting the 4 to 2. So we will be taking the common base as 2. Okay, so this is the second term will remain as it is because it is having the base 2. The first term has to get converted. It will be log of x plus 14 to the base 2 over log of 4 to the base 2 minus log of x to the base 2 is equal to 1. And what is log of 4 to the base 2? It is log of 2 to the power of 2 or 2 squared to the base 2, which will be equal to 2 times log of 2 to the base 2 or 2 times 1, which is equal to 2. So log of 4 to the base 2 is equal to 2. By now, I hope as soon as you, even in our previous session, we had a term containing this thing, log of 4 to the base 2, and we had written 2 in place of log of 4 to the base 2. This is how you come to this answer. Log of 2 squared to the base 2 is equal to 2 times log of 2 to the base 2, which is 2 times 1 or 2. Okay? And the other terms are staying as it is. Now, you can take this 2 as the common denominator for both these two logarithmic terms. And you can write this as 2 times log of x to the base 2 over 2, so that you have a common denominator for all the two terms on the left hand side of the equal to sign. And then cross multiply and you will be having log of x plus 14 to the base 2 minus 2 times log of x to the base 2 will be equal to 2. 2 times 1 will be equal to 2. And 2 times log of x to the base 2 can be written as log of x to the power of 2 or x squared to the base 2. You can do that. It will be log of x plus 14 to the base 2 minus log of x squared to the base 2 equal to 2. That will be a perfectly valid method, but over here what I have done is I have taken this 2 as I have written it as half and made this the coefficient. So it is half times log of x plus 14 to the base 2. Actually, you have multiple ways. For very trivial equations, there is a single method. But as you move to slightly difficult questions, you will be seeing you may be having multiple ways of coming to the solution. Okay? So it is up to you to decide which method you will be choosing, or which method is coming to you directly. Means I could have used the second method as well, but when I was writing this equation, I was solving this equation, this method came to me. So I wrote this. It is not that I don't know the second method, but I have used this method for solving this equation. Okay? Maybe if I have to solve this very equation sometimes later in some other place, maybe I'll be using the second method. Okay? But over here I have made this half. I have written this 2 as half times log of x plus 14 to the base 2 minus log of x to the base 2 equal to 1. And this can be taken and made the power as of x plus 14. So I have done that. It is log of x plus 14 raised to the power of half to the base 2 minus log of x to the base 2 equal to 1. And now since the coefficients of both these logarithmic terms are equal to 1, we can combine them to get a single logarithmic term on the left hand side of the equal to sign. It will be log of x plus 14 to the power of half over x whole to the base 2 equal to 1. Again, you can convert this to an exponential equation, and it will be x plus 14 to the power of half divided by x equal to 2 to the power of 1 equal to 2, which I have done. Or else what you can do, you can write this 1 as log of 2 to the base 2. And then you will be having one logarithmic term on both sides, on either side of this equal to sign, so that you can cancel the log part and you can take the arguments. It will be x plus 14 to the power of half over x equal to 2, because 1 was written as log of 2 to the base 2. You can do that. Write 1 as log of 2 to the base 2, cancel the log of 2 part, log of to the base 2 part, and equate the arguments. That can be done. Or else this is a logarithmic equation converted to an exponential equation. That will also be giving you the same thing. It is x plus 14 to the power of half over x equal to 2 to the power of 1, which is equal to 2. And on cross multiplication, we get x plus 14 to the power of half equal to 2x. Next, we have to get rid of this half, so we square both the sides. We get x plus 14 equal to 2x whole square is 4x square. And this is a quadratic equation which needs to be solved. So we will be having 4x square minus x minus 14 equal to 0. In order to solve a quadratic equation, we all usually take all the terms on one side of the equal to sign and keep the other side equal to 0. So I have done that, and you have to factorize this using the Middleton splitting method. It will be 4x square minus 8x plus 7x minus 14 equal to 0, because it should be the product is 4 times negative 14, that is negative 56, and if you add them, you have to get two numbers from that negative 56, which when added together will be giving us negative x. So the two numbers that should be taken are negative 8 and 7. Negative 8 times 7 is negative 56, and negative 8 plus 7 is negative 1. Okay? So taking these first two terms, we get 4x and x minus 2 within the parenthesis, and from the last two terms it is plus 7 outside the parenthesis, and inside the parenthesis we should be having the same expression, x minus 2, and then the next step is x minus 2 times 4x plus 7 is equal to 0. So we will be getting two values of x from this equation, factorized equation. X will be either equal to 2 or x will be equal to negative 7 over 4. And as I have said before, whenever you have multiple values of x found from from solving a logarithmic equation, you have to check whether you can take all the values or not. X equal to 2, the argument should be, we are not having x in the base, so we do not have to test for that. The argument should be a positive number. When x equal to 2, 2 plus 14 is 16, a positive number, and 2, this is a positive number. So we can take the value of x as 2. But what about negative 7 over 4? X equal to negative 7 over 4, we cannot have a negative argument. So we have to reject this. Okay? So this can be taken, but this should be rejected. Therefore, the final value and the only value of x that we have is x equal to 2. This is our answer for the given logarithmic equation log of x plus 14 to the base 4 minus log of x to the base 2 equal to 1. Okay? So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.